All right, what we're going to work on in this first video is the chapter 8. We're doing it differently where I'm not writing it out. We're just going to look at one. So everybody look for chapter 8, similar polygons, please. Okay, so the first thing you need to know up here for similar polygons is that they have the same shape, but they're different sizes. Remember, this is a dilation. It's either an enlargement or a reduction. There's two rules. They have equal angles. So angles are equal, and then they have proportional sides. And remember, this is when we did big over small, and their sides were proportional. So you had the fractions, and they were all equal. So an example would be you look at the big shape versus the small shape, and you write all the fractions. And if all decimals equal the same thing, then the sides are proportional. The statement of proportionality is this thing, where you locate what's in the same position, and you write it with words. Or not words, but with segments, with letters. Okay? So that's the first stuff that you need to know about similar polygons. Down below on the next section for similar polygons, I wanted to give you some examples. So go ahead and draw the triangles ABC and triangle DEF. And then when you have them drawn, press play so you can continue writing down the notes. So we have to find the scale factor. Since it says ABC, that has to go on the top. And so it's either the 5 or the 12. Well, the 12 is in the same place as Y, so that doesn't work for scale factor. So the scale factor has to be 15 over 8. And again, because ABC is on top, or comes first, it has to be on the top. If I ask for it in the other order, and it says DEF, well, it's either the sides with 3 or 8. Can't be 3 because the 3 is with an X. So this time it's 8 over 15. So scale factor, remember, is when something's in the same location on both shapes. You have a number. And then if I want to solve for X, X is in the same place as 3, but then I have to go back to this triangle, and then I do 15 over 8. And then here to solve it, to get rid of a divide by 3, I multiply both sides by 3. And so 15 times 3 divided by 8 is 5.6. To set up for Y, Y is in the same place as 12. So it's Y over 12. And then I go back to this other triangle, and I pick another side. I'm not going to pick 3 because 3 doesn't have a number with it. So I'm going to stick with my scale factor. So it's going to equal 8 over 15. And then to solve it here, to get rid of a divide by 12, you multiply both sides by 12. And that's it for similar figures. So make sure that you have all of that stuff written down, and when you do, press play again. Okay, and then the final one we're doing is chapter 9. This should be on your back tab. And so there's a couple things you have to know. The first one is Pythagorean theorem. And you use Pythagorean theorem when the only thing you're dealing with is sides. You can't have angles with Pythagorean theorem. It's only sides. And so remember, the only side that's super important is this hypotenuse. And so it's a squared plus b squared equals c squared. And then remember, we also were able to tell what type of triangle it was. If the hypotenuse squared was big, then it's obtuse. If the hypotenuse squared was small, like here it says small, it's acute. So this is Pythagorean theorem, and then this is also how you prove what type of triangle it is. And then remember, we have SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And remember our rules. Step 1 is to circle the angle. Step 2 is label the sides. And remember, when you label the sides, only label the sides you need. Don't label all of them because it might confuse you. If there's a blank side, don't label it. Step 3, pick your S, C, or T. And step 4 is to set up and solve. So remember, that's the circle, label, pick that we talk about a lot. Okay? We've practiced this a lot recently. You should be good on it. Hopefully you guys are doing okay with these reviews.